Hey guys, we're going to do homework for 9-2, right? So let's get started. It says, how can geometric relationships be proven algebraically? So if you remember today, we did that when we took the coordinates of a regular square, our square, and then we used algebra to describe those coordinates. So how was this done? Okay, we used coordinates and graphing with algebra. And I'm going to put in parentheses, what do I mean by algebra? The use of letters or variables, right, in place of numbers to find formulas for any shape, right? And so that's how we actually proved that that would be the case, not just for the square that we drew, but this would be the coordinate for any square that we could draw. And I can put the number, any number I want, in for A. Okay, number 12. It says, show that the diagonals of an isosceles trapezoid are congruent. Okay, so here's our coordinates. And so what would be the distance here? Okay, so this would be an right triangle, right? With what distance? So it looks like it has the height of C, right? Because I went over B up C, so it has the height of C. And let's see what the width is. So it looks like to get over here, I went over B. So this distance here is B from here to here. And now how did I get over to this? It looks like I went back A. So this would be an A, back A. So what is this triangle? Well, this triangle, this right triangle would be the hypotenuse made by, so let's see, this is the distance from point A to point C. So the distance from point A to point C is equal to little c squared plus A plus B squared. And take the square root. Okay. So now let's take a look at what about the other diagonal. So when we look at the other diagonal from B to D, would it have the same dimension? So it looks like I might have to clear out that other triangle to really make room here. So would this one have the same dimension? So if this was a right triangle, we're trying to find this distance. This height again is C, so that's the same. This, I went back B, right? Back B to get to B, back B. So that would be B. This distance is the absolute value. So this distance would be B. And then to move forward here, I moved forward a total of A. So once again, the distance between B to D would be equal to C squared. And this leg would be B plus A squared. And essentially, these are the same thing. So we've shown that, yes, the diagonal of AC is equal to the diagonal of BD because they're equal to the same thing, whatever C squared plus A plus B squared is. Cool. All right, our next question says, number 15, we can use this graph. Makeshift, how would you plan a proof to show that ABC is a right triangle? So A, B, C, this is a lot like our example, our first example. So to find that that's a right angle, I think that the one we were probably the most comfortable with today is this slope. So the slope of AB is, I rise 3, I run 2. And the slope of BC is, I fall 2, I run 3. And we recognize these are opposite reciprocals. We also learned something new today, that if we multiplied them, we should get -1, and that's another way to say opposite reciprocal. So if I multiply 3/2 with -2/3, I get -6/6, which is -1. Beautiful. So how would I write a proof? Just like that. So essentially, it was the same as the proof that we could almost copy it, really. It's the same proof that Dakota wrote, right? To see how that's pretty much the same question. Almost exactly the same question. Cool. Okay, so we finished number 15. The next question they asked for our homework is 18 through 21, which are like example 1 in our notes. Okay, so diagonals of a parallelogram that is not a rectangle are not congruent. Okay, so we can draw with, you'd be wise to probably use graph paper here. So let's import graph paper. All right, so I'm just going to put some graph paper there because it looks like 25 and 26 they haven't assigned me, so I can just kind of cover those up here. So can I draw a diagonal? So I'm going to draw a diagonal, and I'm okay if you use, your numbers. So that's 0, 0, right? And I'm going to go over 2, up 3, over 2, up 3, and I want to make that my parallelogram. And then I'm going to go over 5. Right? And notice that I have to do, if it's a parallelogram, the slope of this is up 3 over 2. I got to do the same thing here, up 3 over 2 to make a parallelogram. All right, so that's my parallelogram. Now it says prove that those cannot be equal. These diagonals can't be equal. So if you recognize here, that's the hypotenuse of a triangle that's 3 by 3. So A, B, C, D. The diagonal, the distance BD, is equal to 3 squared plus 3 squared. And the other diagonal is going from A to C. Notice that's much longer. It is the hypotenuse, the distance between A to C, which is the distance of that diagonal. It's the hypotenuse of a right triangle that is 3 high, and it looks like it's 5, 6, 7 wide. So when we look here, we're getting different numbers. So we can say the diagonal of AC is not equal to the distance between BD, the diagonal, because these are not equal to each other. Very, very different. We get a long one and we get a shorter one. 19. What is the length of the diameter of a circle twice that of its radius? Okay, so let's think about that for a minute. So to draw a circle, I haven't really shown you how, but I tell students you want to go left 2, right 2, up 2, down 2, whoop, there's a circle, okay? So I made this the length of a diameter of a circle. So I'm going to call that D for diameter, right? No, I'm going to call that D for diameter, right? Radius. Radius is halfway, diameter is all the way. The length of a diameter of a circle is, so D is twice that of its radius. So my radius is 2. D is 4, and it says is twice that of my radius. I'm trying to be cool and color coordinated, and it's not working. Okay. My diameter of 4 is equal to 2 times my radius. Now, how could I prove that? Well, I could then make a larger circle, that big, right? 3 up, 3 down, 3 left, 3 right, bada boom, bada bing. This diameter is 6. This radius is 3. So once again, my diameter is equal to 2 times my radius, because my diameter 6 is equal to 2 times my radius of 3. 20. The diagonals of a parallelogram bisect each other. Okay, prove it. So I could probably actually use the same parallelogram I have up here. So let me just redraw that. Okay, so the diagonals bisect each other. So, actually, you know what? I want to do, we like it when we cut numbers in half. So I actually want to do one that would be very obviously fall in the middle here. So let's see if I can try to sketch one that would make it obviously fall in the middle. All right. Okay, I think I did that. Okay, so I made a parallelogram, and it's definitely a parallelogram, and I'm trying to prove that that point is in the middle. So let's read off these coordinates. So A is 0, 0, right? B is 1, 2. C is 5, 6, 2. D is 5, 0. So we're trying to prove that, and I'll call this E. We're trying to prove that E is the midpoint of BD, and prove that the E is the midpoint of AC. Pretty cool. So let's just use our midpoint formula that we did review today, right? So our midpoint formula, add the 2x, divide, add the 2y, divide, and see what we got here. So our point E is 3, 1. So finding the midpoint of BD, we take coordinate, so the middle of BD is, add the 2x, so we're going to add 1 and 5. Divide by 2, and then add the 2y, 2 and 0, and divide by 2. So we get 6 over 2, 2 over 2. So we get, what do you know? Same. So we've success so far. Now we have to find, is that the midpoint of AC? So is that the midpoint of AC? So we're going to add the 2 x's, 0 and 6, and divide by 2. And add the 2 y's, 0 and 2, and divide by 2. And what do you know? We get that same coordinate. So we've proven it. 21. The area of XYZ is twice the area of XWZ, where W is the midpoint of, oh, we gotta get to drawing here. Okay, so we're not doing number 27. So let's go ahead and add some more graph paper in. Okay, there you go. So it says the area of XYZ. So okay, that's a triangle. So let's make just a basic triangle. So here's my triangle. The area of this triangle, the area of my triangle, 1/2 base times altitude. My base is 4, right? My altitude is 3, so I get 12 halves or 6. So the area of this triangle is 6. Now it's saying X, Y, Z. The area of the triangle is twice the area of XWZ. XWZ, where W is the midpoint of XY. Okay. W is the midpoint of XZ. All right, rewind. I kind of want a midpoint that's not a, I kind of want a midpoint that's not a half coordinate. So I'm going to make this, no, I'm going to make this Y. I'm going to go Z. Yeah, because that's still, the area is, that's still a true statement. Yeah. But now it's saying, I want W to be the midpoint here, and I like that it falls right there, okay? So what is my triangle XWZ? XWZ is this triangle. It's like a really interesting triangle, isn't it? How can I find the area of this triangle? Well, the area of that triangle, the area of the green triangle, plus the area of this leftover has to add up to my original orange triangle, doesn't it? So my original orange triangle is 6. So if I find out the area of this leftover triangle, I can subtract it off there to figure out the area of the green one. This is a very cool question. Okay, so what is the area of this leftover? This is my leftover. So let's find the area of XYW. So the area of XYW is 1/2 base times altitude. So 1/2 looks like the base is 3 and the altitude is 2. So that's 6 over 2. So that's 3. Yeah, so if the area of this is 3, and the area, we don't know what that is, but 3 plus x is 6. If we subtract 3 from both sides, we know that this has to have an area of 3. So that is a true statement. We've proven it. Nice. Okay, so let's go ahead and do 22 and 24. 22 says, the length of a diagonal of a rectangle is the square root of the sum of the squares of the lengths of the two adjacent sides. Okay, yeah, I think we already proved this. So if we have a rectangle, and I think we used this in class, like a 3x5 rectangle, then the length of the diagonals, and we proved in class they're equal. So the length of this diagonal is, so let's call this A, right? When we did this, we call that B. So essentially here, the length of that line, we'll call that BD, is equal to 3 squared plus 5 squared, and take the square root. So if we change to letters, it's equal to A squared plus B squared. We proved that in class. So they're saying the same thing. It's saying that it's the square root of the sum of the squares of the lengths of the two sides. That's exactly what that's saying. All right, 24, it says, one and only diagonal of a kite bisects the other. One and only diagonal of a kite bisects the other. Okay, so let's show that down here. We saw in, not this class, but last class, a graph of a kite. It was kind of interesting. It went up 4, and then it went over 4. So it was really easy to kind of see these two lengths are the same. So I like that. Let's keep that. And then it went like, from this point, I think it went up 1 over 5. So it landed there. Notice here as well, this one goes 1, 5. So this will be a kite because these two lengths are the hypotenuse of a 1/5, and this length is like the same thing, the hypotenuse of a 1/5. So this is definitely a kite. This and this are both equal to this distance. Nice. So prove that only one diagonal bisects. So notice here, oh yeah, that diagonal bisects. We can see that visually very obviously. So let's prove that. If I find my midpoint, so let's rattle off. So point B is 0, 4. Point D is 4, 0. What would be the midpoint? Here it looks like, and I'll call this E, it looks like point E is 2, 2. So can I use the midpoint formula to prove that? We're like, well, sure. The midpoint of BD would be add the two x's, divide by 2, add the two y's, divide by 2. And what do you know? That's true. So that one's cut in half, but this one very obviously is not. So let's prove that. And the midpoint of AC is, well, A is 0, 0. C is, it looks like we went over 5, up 5. So we add the two x's, and we add the two y's, and we get 5 halves, 5 halves. So what's that? 2.5 comma 2.5. And we've proven it. That is not equal. The point 2.5, 2.5 is not the same point as E, 2, 2. So we've proven that that one did not get in half. Check out the next video for the rest of the assignment.